Today we're talking about the law of conservation of mass. This law says that matter cannot be created or destroyed in a chemical reaction. So that means that the amount of atoms that we begin with in our chemical reaction is the same as the amount of atoms we end with in our chemical reaction, or the amount of mass we begin with in our chemical reaction is the same as the amount of mass that we end with. Now, it can look totally different. If you're thinking about some of the chemical reactions we did last week, it can look totally different. Even if you burn paper, you start with paper and fire, they react, and at the end, that paper looks different. Now you have ashes, but the mass of the paper in the beginning and the mass of the paper and the ashes in the end is the same. Matter can't be created or destroyed. It can be changed. It can look different. It can go from paper to ashes, but nothing is created or destroyed when we are talking about the amount of matter. So a way that this is represented or shown is through a chemical reaction, or a chemical equation. I'm sorry. We know what a chemical reaction is. A chemical equation. So make sure you put your title. Sorry, I already had it written. Make sure you put your title and the law. And then we are going to write out a chemical equation so you can see what that looks like. Okay, so this is one example of a chemical equation. And a chemical equation is made of three parts. This first part on the left side is called the reactants. Reactants. Say that word, reactants. In the center, we have our arrow. And on the right side, we have the products. It is important that you know that the left side is the reactants and the right side is the products. So that a way you can remember this is by remembering R-A-P, RAP. Reactants, arrow, products, RAP. That's how you remember the order. So let's talk about what are reactants. So I'm going to kind of box this off for us, and we are going to put 2 bullet points. These are the elements or compounds that go into a reaction. So if we were using an example of baking a cake, if we're going to go bake a cake, these reactants are going to be our ingredients. Now, the actual mixing of cake ingredients is not a chemical reaction. Remember that mixing is not a chemical reaction, but the reactants are what you start with. They're your ingredients. So I'm going to put example cake ingredients. Okay, then our arrow is actually said as yields. So you would read this H2O4 plus C yields CH2O4. So the arrow is actually stated as yields, and what it is an equal sign. It means equals this plus this equals this. Milk plus vinegar equals chunky milky vinegar. All right, and then our last section is our products. And our products are what is created in the reaction. So we're baking a cake. We have all of our ingredients. Those are our reactants. Mix them together, and then we put them in the oven. When they're in the oven, that's where our yields is happening. They are reacting, and our result would be an actual cake. So reactants are like your ingredients. The product is your result. It's the product you end with. So when we're baking a cake, it would be the cake. When we were talking about the lab we did last week, this is your before, which you saw before. Those are your reactants, your ingredients that were sitting out. You complete the reaction, and then this is your product. This is what is seen at the end. This is your end result. So, I mean, this probably sounds fine. No big deal. But there's two ways that you can be asked about this. You could have to count the number of atoms, and to prove the law of conservation of mass, we would have to prove that matter was not created or destroyed. So on this side, I have 2 atoms of hydrogen. On this side, I have 2 atoms of hydrogen, so they're the same. 4 atoms of oxygen, 4 atoms of oxygen, 1 atom of carbon, 1 atom of carbon. So this equation properly shows the law of conservation of mass. No matter was created or destroyed, but it was changed. It looks different. There's another very common way you will see this. So let's write a couple examples. Example 1. All right, so we'd be given a chemical equation. So let's say we're given 6Al plus 3S8 yields 8Al2S3. Now, y'all don't know what these big numbers mean. So if you're given them, you don't need to worry about them. You don't need to know what they mean, because what they will give you underneath this is they will give you the masses. So this element, Al, used 45 grams of this element in the reaction. And for this element, S8, they used 63 grams in the reaction. And you know what? I made a mistake. I shouldn't have put my plus sign, because I want to show you exactly how it will look. It will look like this. It'll have a 45 here, a 63 here, and a question mark here. So let me show you how to solve this. You would be given this, and you would be asked, what was the mass of the product? We need to determine the mass of the product. This is so easy. All you have to do, little tricks, is you drop your arrow down. You drop your plus sign down. So I'm drawing an arrow to show you bring it down. You have to write that plus sign. It's not going to be there for you. You have to know to bring that down. You drop your arrow down as a equal sign, because the arrow means equal. So now you have a math problem. Piece of cake. Yeah, I got this. 45 grams plus 63 grams equals how many grams? Both sides have to be equal. If we started with 45 plus 63, we have to end with whatever 45 plus 63 is. So this would mean that our arrow equals 108 grams. That's your answer. So it looks weird. I will admit that. These questions look weird. But you drop your plus sign down, you change your arrow to an equal, and you have a basic math problem. You can solve 45 plus 63. You could do that in elementary school. Let's do another one. Sometimes the question mark won't be where the product is. It could be on the reactant side. So let's do one like that. First, they'll give you an equation. C6H12 plus 9O2 yields 8CO2 plus H2O. And you'll be given all right, so this is exactly what you would see on a question. You're not writing any of this for a question. This is what you would see on the question. You would be asked, what is the missing mass of the reactant? All right, So we follow our steps I just talked about. Drop your arrows down. So bring my plus sign down. I'm sorry, drop your plus signs down. I keep saying that. Bring my plus sign down. Bring my plus sign down. Change my arrow to a what? Equals. And then I like to rewrite it so that it looks easy like a math problem. So I would rewrite it as 60 plus x equals 20 plus 140. To me, this now looks like a math problem that's not intimidating, something that you could solve. So if you're in math class, what would be your first step for solving this? Yeah, you need to add. So now you have 60 plus x equals 160. What would be your step now? How would you find what x is alone? You would subtract 60 from each side. So then x equals 100. So to answer our question mark, or our missing reactant is 100 grams. And you can always go back and check your work. If you plug that 100 in here, you have 60 plus 100, so 160 equals 20 plus 140, 160. According to the law of conservation of mass, both sides have to be equal. I strongly urge you to use paper when you do these problems because your problems will be on the computer. But I urge you to use paper and write it down like a math problem. So put the plus sign. I like to change the question mark to an X because that's what you're more familiar with seeing in math class. And then solve it just as you would a math problem. What we are proving, what we are showing is the law of conservation of mass. We are showing that matter cannot be created or destroyed because in our equation, the reactants had the same mass as the product. The reactants had the same mass as the products.